Welcome to my lecture on stresses on ships. My name is Dr. Sam Tawfiq. Today, we'll explore the types of stresses that affect ship structures and their implications. Definition of stress. Stress is defined as the load or force acting per unit area, typically expressed in kilograms per square millimeter. It is a critical factor in assessing the structural integrity of a ship. Definition of strain. Strain refers to the deformation or distortion experienced by a material as a result of applied stress. Types of stresses. Stresses can be categorized into three primary types. 1. Compressive stress, forces that act to shorten or compress a material. 2. Tensile stress, forces that act to elongate a material. 3. Shear stress, the result of two equal and opposite forces, acting parallel to a material's surface, causing layers to slide past one another. Forces acting on ships. Forces acting on a ship can be classified as either static or dynamic. 1. Static forces. These are due to the weight of the ship and its buoyancy, which are distributed throughout the vessel. 2. Dynamic forces. These arise from the ship's motion through water, as well as from environmental factors such as wind and wave. Types of stress in ships. The forces acting on a ship create several types of stresses. 1. Longitudinal stresses. 2. Transverse stresses. 3. Local stresses. Longitudinal stresses. 1. Hogging, when a ship's hull is curved such that the bow and stern are lower than the center, typically occurring when buoyancy amidships exceeds the weight of the ship. Continue. Longitudinal stresses. 2. Sagging. This condition occurs when the center of the ship is lower than the bow and stern, usually resulting from the weight amidships exceeding buoyancy. Continue. Longitudinal stresses. 3. Shearing force. Shearing force refers to the tendency of forces to displace a section of the ship laterally, particularly at bulkheads. This force can result from uneven distribution of cargo within the ship. Transverse stresses. Transverse stresses occur in the midsection of a ship due to static water pressure and internal loads. Key types include 1. Racking stress. This stress occurs when the ship rolls in waves, causing distortion in the transverse direction. Continue. Transverse stresses. 2. Torsional stress. This stress arises from twisting moments acting on the hull, particularly when the ship is moving diagonally to wave action. Continue. Transverse stresses. 3. Water pressure. The pressure exerted by water increases with depth, leading to fluctuations that can affect the ship's hull. Local stresses. Local stresses can manifest from specific conditions such as 1. Panting. This refers to the tendency of the hull plating to flex in and out due to fluctuating pressures when the ship is in rough seas. Continue. Local stresses. 2. Pounding. This occurs when the ship's hull is driven into waves, causing sudden impacts on the structure. Continue. Local stresses. 3. Concentrated loads. Heavy weights placed on the deck can cause localized deflections and inward or outward movements of supporting structures. Continue. Local stresses. 4. Dry docking stress. This stress results from the pressure exerted by dry dock supports and keel blocks on the shell plating and associated structural members. Conclusion. Understanding the various types of stresses that ships experience is crucial for ensuring their structural integrity and safety. Proper design and material selection are essential in mitigating these stresses and enhancing the vessel's performance in varying sea conditions. With my best regards, Dr. Sam Tawfiq.